Hi guys, welcome to my first video on H4 Maths. Today I'll be telling you how to do roots of polynomials. Every further math student has to know the relation between the roots of a polynomial and that polynomial's coefficient. You'll probably get 3 markers on that. That's the most common, but it's very easy to trip up. I'm gonna delve into a bit behind the proof of the different relations, so minus b over a, c over a. I'm going to say why that's the case. I'm going to show how you can use it with some examples, and finally I'll show you why we can do it, why we find the relations. We can transform equations, polynomials, using the roots. So for example, we can find if we have a quadratic, we can find the quadratic with the roots squared, basically. And we're going to go up to all the way to quartic equations, which are in the syllabus. Now this video is targeted towards further math students. However, if you're an AP student in another part of the world, international A-level, this may be targeted towards you as well. Or if you just want to know more about maths like I do. Okay guys, so we're going to start by writing down a normal quadratic equation with a as the leading coefficient of x squared. So ax squared plus bx, sorry this board is a bit wobbly, plus c. Now every quadratic equation can be written as a factorized version of its roots, real or not real, doesn't matter. So this will be equal to a, if we have the roots alpha and beta, x minus alpha times x minus beta, as you guys know. And if this were to be equal to 0, the roots would be alpha and beta, and a as the leading coefficient. Now we have the left hand side and the right hand side, right? We're going to expand this side and we're going to compare the coefficients, and we're going to see how do the coefficients relate to the roots, and we'll delve in a bit into why that is important. So let's just do this. So we're going to expand these two brackets. X squared minus alpha x minus beta x plus alpha beta. Now we're going to distribute this a onto all the terms. Now that we've expanded, we've distributed the a, I'm just going to speed this up. We're going to do ax, we're going to simplify it. So this is ax squared, pen's not working. And then we're minus a, we're going to take a minus a, leaving alpha plus beta x, right? Because we have minus alpha x, minus alpha beta x. Factor out a minus a, we're going to get the coefficient to be minus a times alpha plus beta, and that's the coefficient of x. And we're going to say plus, we're going to keep that as alpha beta. Now, if we're going to go to back to the top equation, we can see that we can compare the coefficients. So if we compare the coefficient of x, we can see that b is equal to minus a times alpha plus beta. b is equal to minus a alpha plus beta. Therefore, alpha plus beta, moving this minus a to the other side, is equal to minus b over a, right? So we have this is one of our first relations, right? Alpha plus beta equals minus b over a. The sum of the roots of the polynomial will always be minus b over a. Now we're gonna do for c, so the one without x, coefficient of x. So c, we're gonna see is gonna be c. So the whiteboard is looking a bit messy right now, but hopefully it's making sense to you guys. C is equal to a alpha beta, that's the coefficient. A alpha beta, therefore alpha beta is equal to c over a, bringing this a to the other side. Now we've proved the second part. So this is for quadratic, right? In the AQA further maths course, we need to look at cubics and quartics as well. So now I'm gonna show you the steps to the cubic equation. Okay guys, so did that. What we're gonna do here is we're gonna do the same as we did for the quadratic. We're gonna compare the coefficients. B for x squared is gonna be, so b is equal to minus a alpha plus beta plus gamma. Now we can see a theme here. which is, well, a theme starting to occur, which is the sum is always going to be equal to minus b over a if we carry this a over to the other side. Now if we compare the coefficients for x, we can see that c is going to be equal to alpha beta plus beta gamma plus alpha gamma, okay? And then we can see that d is going to be equal to a alpha beta gamma, therefore alpha beta gamma is equal to d over a. I'm going to show you the general form. So minus b over a is equal to the sum of roots, basically, is going to be equal to minus b over a. So for quartic, it will be alpha beta gamma delta. C over a is going to be the sum of alpha beta, but for example, a cubic equation and a quartic equation, it will be alpha beta plus alpha gamma plus beta gamma. For quartic, it will be all that, but throw on a delta as well. Now, minus d over a here is going to be equal to the sum of alpha beta gamma. So obviously for a cubic equation has 3 roots, so it'll go up, this is basically like the product of all the roots. For a quartic equation, will be alpha beta gamma plus alpha beta delta plus we'll go all the way, going through all the possible combinations of the roots. Then finally we have for the quartic equation, e over a is equal to the sum of alpha beta gamma delta. And here we have everything you need to know for the AQA syllabus on that topic. Yeah, this is a simple one. I just wanted to expand on why this works. And you can see you can have a theme. It's very easy to remember. Negative, positive, B, C, D, A, E.